thing to remember here is that average rate of change is just a fancy way of saying slope. So if really all you need to calculate is slope, think about what you need for slope. Remember, the formula is for slope is y2 minus y1 over x2 minus x. Well, what I need to be able to calculate slope is two ordered pairs. When it gives you the interval, it's essentially giving you the x values. So if I have two ordered pairs, 0 is my first x, or x1, 4 is my second x, or x2. Now I just need to figure out what are the y values associated with that. Go over here. When x is 0, or specifically at 0 hours, y is 12, or specifically 12,000 gallons of water. I'm going to use 12. Just understand that that represents 12,000. It's easier to calculate that. When x is 4, or specifically after 4 hours, there are 4,000 gallons of water left in the cistern. So now we're just going to use the slope formula. That's x1, that's y1, x2, that's y2. 4 minus 12, y2 minus y1. 4 minus 0 is x2 minus x1. You end up with negative 8 over 4, which would reduce to negative 2. Now, again, since 1 unit on the y scale is 1,000 gallons of water, negative 2 really means negative 2,000 gallons per hour. So essentially, the context is the cistern is draining 2,000 gallons per hour. The average rate of change would be negative 2,000. What is a possible explanation for what this rate of change indicates? I think that's what I just said, so let's find the answer there. The water in the cistern is being used at this rate of gallons per hour. It sounds reasonable. The water in the cistern is not being used, and the cistern is not being filled, so that would mean it would be flat. So that's not true. The cistern is being filled with water at this rate. That's not true. If it was getting filled, the average rate of change would be increasing. The value represents the amount of water that was originally added into the cistern. Now, the original amount of water was 12,000. So I think the most reasonable answer here is A. The water is being used or taken out of the cistern at that rate. Okay. What is the average rate of change on the interval 6 to 10? We're basically going to do exactly what we just did for the first part. So we're going to find the slope. Now we're specifically talking about from 6 up to 10. So my x coordinates of my two ordered pairs are 6 and 10. Let's figure out the y values associated with that. So after 6 hours, there are 4,000 gallons. After 10 hours, there are 10,000 gallons. So I just need to figure out the slope between those. So again, y2 minus y1 would be 10 minus 4. x2 minus x1 would be 10 minus 6. You end up with 6 over 4, which is 1.5. All right. Again, the y value represents thousands, so I need to multiply that number by 1,000. So instead of being it's 1.5 thousand, if you want to think about it that way, which was really 1,500. Okay, so the average rate of change is 1,500. Gallons per hour. So it's getting, since it's positive, that means it's getting filled. Okay. What is a possible explanation for this rate of change? So it's a similar question to the last one. A, the water is not being used. That's not true. It's increasing. The value represents the amount of water that was in the cistern. At the end of the time interval? No. The average rate of change does not represent how much is left. How much is left is 10,000. That number is not that. Water in the cistern is being used. So again, we discovered that on the last question, being used means being drained out. The cistern is being filled with water at this rate. So that's the answer. 1,500 gallons per hour is being filled into the cistern. All right, part B. What is a possible explanation for what occurred between 4 and 6? So if I go back and look, between 4 and 6, it's flat. So, I mean, without looking at the question yet, my thought would be that it's just not being used. People took a break, whatever, because it stayed flat. So let's see, I would say the water in the cistern is not being used, and the cistern is not being filled with water. Neither of those things are happening, right? Because it's flat. Therefore, the amount of water in the cistern is constant. It's not increasing or decreasing. It's flat. It's constant. What is the average rate of change on the interval 0 to 10? So now we're looking at the average rate of change over the whole thing. It's not going to be a slope of a line, but it is still going to be, we're still going to calculate it the exact same way. So we're starting at 0, and we're going all the way to 10. So really what we're getting is the slope of that imaginary line there. Right away, my expectation is we're going to get a negative rate of change because it ends up lower than it started, or the amount of water in the cistern is less than it was when it started. So we're going to get those two ordered pairs and find the slope between that, of that imaginary line. Again, the x value, the first x value is 0. The second x value is 10. Now he's going to go to the graph to get the corresponding y values. Well, at time 0, there's 12,000 gallons, so we're going to want to use 12. And at hour 10, there is 10,000 gallons. All right, we're going to find the slope between them. So 10 minus 12 over 10 minus 0. So you get negative 2 over 10, which would reduce to negative 1 over 5. And then if you made that into a decimal, it'd be negative 0.2. I multiply that again. These numbers, the y values are in thousands. So instead of using those big numbers, I'm going to multiply by 1,000 at the end. I multiply negative 2/10 by 1,000, I get negative 1. Okay. So I'm going to enter that in. Our answer. All right, what does this rate of change mean? Well, let's read the answer choices, then we can talk it out. The water in the cistern is not being used, and the cistern is not being filled. Well, obviously, there was some change, right? So answer choice A is not true. The only way that that would potentially be true is if the average rate of change was 0. But even still, if you emptied it and filled it and it ended up being back where it started, that doesn't also necessarily mean that it wasn't being used at all in between. All right, but answer choice A is out. Answer choice B, the water in the cistern is being used at this rate of gallons per hour. Potentially, the cistern is being filled with water at this rate. Potentially, but both those things happen. So I don't think either of those are your best answer. And then D, the value represents the amount of water that was originally added into the cistern. All right, that's not true either. So I'm going to go with answer choice B. The water in the cistern is being used at this rate of gallons per hour. Okay, so over the course of the 10 hours, on average, it was being used at 200 gallons per hour, even though the reality is it was used a lot at the beginning and then it was filled at the end, right? But in an average at the end, they used about 200 gallons per hour. Does this rate of change give a good indication as to what is happening with the water in the cistern from 0 hours to 10 hours? So I would say no, because again, what we just talked about is it's just showing you from the beginning to the end. It's not necessarily like if I just knew that the average rate of change from the beginning to the end was negative 200, maybe that means it was just used 200 gallons per hour over the whole entire course of the day. That's not what happened. It was used a lot at the beginning and then it was filled at the end. There was a flat spot in the middle where it wasn't used at all. So I think the best answer is C, where it says no, this rate of change shows the change from the starting amount to the ending amount. It does not show the amount the water increased or decreased within certain intervals, during the day. So I think that's the best answer. Okay. Let me know if you have other questions.